Okay, we are at another kind, which is speed time curve. So instead of having a graph like earlier, we're going to look at a speed time curve, and it's like a very standard curve question, where a function question where you draw. So the first step you have here is to find the values of based on this whole question. A particle moves along a straight line and its speed is given by the function v equals to 3t squared minus 15t plus 20. So in this case, it's great, we have a function, okay, and we tell you a table of values. So the table below tells us certain things. So with a table, this gives us a lot of advantage, in fact. So the first step is to find a and b. So to find a and b, you simply just use your calculator. Okay, so right here, if I'm not wrong from what I did previously, it should be a equals to 4.25 and b, which is supposedly, I think it's 1.25 if I'm not wrong. Yeah, 1.25. Okay, so I did it already. So okay, and then for the second part, you just need to draw, which is pretty simple. So I've already drawn it here. Okay, so now we have the graph. We're going to use our graph to estimate certain things. The first step here is to estimate the value of t when the speed of the particle is 10 meters per second. This is pretty straightforward, but one thing you need to take note is that when the speed is at 10, it actually cuts the graph at 2 points. Okay, so you need to draw a dotted line from here. Okay, it's not dotted now, but it will be dotted in a while, and it cuts the graph at 2 points, and you need to estimate these 2 points over here. Okay, I think there is also a margin for error, so just be careful. There should be 0.8, and here would be this is slightly different. Okay, so this one would be slightly different. Same thing, you just have to estimate it. This is about 4.25 or 4.22. Yeah, okay, just estimate it and you'll be fine. So for part A, okay, we have that t is equals to 0.8 or 4.25. Okay, find the time at which the acceleration of the particle is 0. So it's very interesting. Just now we said that to find the acceleration for a speed time curve is actually to find the gradient. So actually what this question just simply means is that you're trying to find at what time is gradient equals 0. Okay, so if you look at it, okay, one thing we learned is that for a gradient to be 0, okay, it will always occur at the turning point. Correct? So this is the only place where gradient will be equal to 0. Because why? Because it will be a horizontal line. The tangent is a horizontal line. So if the tangent is a horizontal line, gradient will definitely be equal to 0. So they ask you to state the time. So it is in fact just 2.5. Okay? So the answer here is t equals to 2.5. Okay, at gradient equals to estimate the gradient at t equals to 4 and explain what this value represents. So we're going to find the gradient at t equals to 4. So you draw a line. If I had a ruler, it would be so much easier. But unfortunately, I don't on the screen. So it should be something like that. Okay, if I'm wrong, I'm sorry. But it should be something like that. Okay. This is not working for me, but yeah, it should be something like that. Okay. This should be the gradient, this line over here, and we want to use this line to estimate the gradient. So what I'm going to do is going to use 2 points. Of course, I'm going to use this. I would love to use this point over here. So this point here would be 4, actually I have it here, right? 4,8. Okay, let's find another beautiful point. Let's find a point where it's equal to 5. Why did it move? Okay, yeah, great. Okay, so when it equals to 5 over here, so I'm gonna use this point over here. Oh, it's a bit Okay, maybe I'm going to use this point over here because it's a bit nicer. So this point over here, it's I would say it's about 4.8 comma 15. So we have something nice here, and the gradient at t equals to 4 would simply be equals to 15 minus 8 divided by 4.8 minus minus 4. Okay, bear in mind the units also. So the v should be in meters, meter per second, and t is in terms of seconds. So just be careful. So this is equal to 7 divided by 0.8. Okay, just plug this into your calculator. So if you have a calculator, it will be so much easier. And you have 7 divided by 0.8. It would give you a gradient of 8.75. Okay, you should have a plus minus of like 2 or 3 values. So the gradient represents, okay, gradient equals 4.75, and this value, and it represents the, because this is a speed time graph, right, represents the acceleration. Okay, so let me close my calculator. Represents the acceleration. Okay, find the time interval when the speed of the particle is less than 15 meter per second. So we're just going to find the time interval in which, okay, it will always be lesser than 15 meter per second. What does it mean? So let's first find out what are the time at which it is at 15 meter per second. So from my line over here, where v is equal to 15, we have two values. One is here. Oops, sorry. Okay, one is here. Let me just quickly extend it down. Okay, and at this point it's about maybe 0.35 seconds, and over here this is about, I would say, 4.68, 4.69. Okay, so if you think about it, right, the time between 0.35 seconds and 4.69 seconds, the speed will always be lower than 15 meter per second. Right? I say again. So between the highlighted one, 0.35 and 4.69, can you see that the speed will always be lower than 15 meter per second? Right? Why do I say so? All these values here are all lesser than 15 meter per second, and these are all, okay, these values here, these values of, this of velocity, okay, will always be lesser, and hence for the time interval would be between 0.35 and 4.69, and that is exactly the question. So just estimate 0.35. What is it? 35? So yeah, 35 less than or equal. It should be less than, because if it's equal, it will be equal to 15. So we don't want that. So okay, t must be is the time interval. Okay, it should be an inequality between 0.35 and 4.69 seconds. So this is actually how we actually kind of like estimate and read off speed time curves. Okay, so that will be all for work example 9.